Someone said, let's start emailing the profs with all of these different things because all the emails look the same. And so I'm like, okay, I know what's going on.
Yeah.
So it'll all be okay.
I feel like results would be a little skewed because
Sorry?
results would be a little skewed because some of us listen to your lectures on YouTube from last
No,
year.
you shouldn't. You should not. You should just listen to her lectures, not mine.
Yeah.
Like they're
I ended up listening to hers.
yeah.
I mean yours.
No, you shouldn't. You really shouldn't. It's her course,
I know.
and it's all her. Like it's her questions. It's all her. So. All right. And can I get back to the other? Oh no, I can hear my voice on the internet. The presentation mode. And how do we not how is it not going there? Send to people. So far. Okay. All right. All right, Mystica. Yay. Yay. Wait, and you're gonna grab your stuff. We still have like about 3 or 4 minutes. Grab whatever you need to. Then come down, just make your announcement. I'm gonna post the details on Quirkus directly as an announcement.
Because I could just put in the.
Yeah, how about during the how about during the actual break while we're kind of waiting, like you can put up your slide and you can set up Kahoot and all that stuff. Oh,
You could do that now for during the break because I might just.
okay.
Better because
Yeah.
I'm kind of seeing anyway. I'll be
Sure.
down here.
Sure. You're the boss. The ever dwindling class attendance. Every single time. All right. Let's see. Sorry, could I ask, did you just take pictures of the food? Did you just take pictures of the food? Okay, just curious. All right, everyone, how are you all doing? Okay. So I think if it's okay with you, we're going to try to get going. We have a lot of ground to cover today. So just to make it really clear, today's lecture is on term test number 1. And so this week is preparation week. So what we're going to try to do in lecture today is to orient you a little bit about what you need to know, what type of information you need to know on these various slides. So there's some that you're very used to because we've covered it the same way, and they're all like bullet point driven. And then there's some data driven slides where it's just like graphs. What should you know about those graphs? What should you expect in terms of your term test based on the data that's coming out of those graphs? So we're going to go through all of that today. And the material on the term test is actually covering today's lecture, and it's quite a bit. So I'm going to point out a few slides as I go along. So hopefully that'll be good for you. So I am going to actually go back and cover a few slides again, and I'm going to extend the story that we've developed on those particular slides as we go along. So you are going to be responsible for sort of the expanded story that I'm going to be covering today, not on every single slide, but on about 2 of them. Then we're going to talk a little bit about trying to make this link, because we've been starting off with like insulin resistance as part of this bigger story around metabolic syndrome. And what we tried to develop as a story is that metabolic syndrome underlies this chronic low-grade inflammation, and how all of these things are related to mental health. And that's ultimately where we're going. And we started into talking a little bit about mental health, depression, but in fact, there are many different forms of like depression, anxiety, bipolar disorder that probably also involve this inflammation as well. So we're going to rethink depression as our mental health story, as an inflammatory process, and to make this link with metabolic syndrome that we've been looking at before. Hopefully, by the end of either the first hour or early in the second hour, we'll be able to have a discussion about how to wrap all of this up, and we'll do this using like Kahoot. So some of it will just reactivate what you've learned before, and then I'm going to go through some really quick notes about make it equitable for everyone, realizing that as students or people who have lots of things going on, that we are going to stream it live, and we will post the stream ahead of time. And we will take a recording of it as well. But if you happen to be available, we will give you directions to the room in New College, and we'll start at around 1 o'clock. Sound like a plan? Is that all right? Okay. I didn't hear yes, so I'm just going to assume. It's okay. All right, we'll go for it. All right, so this one is, there's nothing new that I'm going to be covering on this slide. Just a couple of things to re-emphasize, and you'll understand why I'm re-emphasizing it on this slide. And we were talking about the differences in the molecular makeup of the different types of adipocytes that we find viscerally, especially when we talk about metabolic syndrome. And as a way to characterize metabolic syndrome, insulin-resistant type 2 diabetes is one way to kind of look at that as a larger metabolic syndrome. We looked at different properties of some of these adipocytes, changes in adiponectin, changes in resistin levels. We didn't really talk about RB4, but just to make the case clear, and as a review, that there are differences between visceral and subcutaneous adipocytes. And then we talked about a transplantation study that you also took up in tutorial last week as well. So hopefully that's all sort of still relatively fresh in your minds. And again, here is that other molecule, adiponectin, and you should know the relationships between adiponectin, resistin, etc. We sort of transitioned very, very briefly in a discussion about beige adipose tissue, and brown adipose tissue is something I'm going to talk a little bit about today. This type of adipose tissue is really important for thermogenesis, so the generation of heat. And I'm going to come back and cover that in a little bit more detail on the next few slides. And the importance of this is really related to all of the mechanisms we've looked at before, but in particular UCP1. Does anyone remember what UCP1 is? Like, what does it stand for? What is it an acronym for? UCP1. It's the molecule that we find before UCP2 and right after UCP0, right? Right. Okay, thanks. Anyone remember? Yes, Omar. Right, so uncoupling protein, and where would we find it? Because that's also important for your term test as well. Where do we find it? What organelle do we find it in? Mitochondria, perfect. Okay, great. So that's going to be part of our discussion. And in fact, here's where we're going to go back into this discussion, and it's really important that you understand that here, it's not the same sort of discussion that we had earlier. Some of these are going to be extended. I'm also going to point out, for some of you who don't have a lot of neuroscience or neuroanatomy background, what you need to know from this story. So we had talked about adipocytes. Adipocytes release leptin. Leptin is going to be released at different times after a meal. And this molecule leptin is going to work on its receptors that are found in two different areas of the hypothalamus. The hypothalamus has two groups of neurons that contain receptors for leptin. One group of neurons is called the arcuate nucleus in the hypothalamus, and the other group of neurons that I'm going to spend a little bit more time on today are neurons that are found in a nuclei that's found in what's called the ventral hypothalamus. They're two separate and distinct groups of neurons. So when leptin binds to the receptors that are found on the neurons here within the ventral hypothalamus, it actually activates the sympathetic nervous system. And the sympathetic nervous system, as many of you know, causes the release of norepinephrine or noradrenaline. So that part I'm hoping is a review for you. And again, on the adipocytes here, so this is an adipocyte, so we're making a full circuit on the adipocytes, and in particular, where we have adipocytes that are rich in mitochondria, or if we are trying to transition different types of adipocytes, so subcutaneous white adipocytes, we want to convert them to the brown adipocytes, one of the things that has to happen is that through this sympathetic nervous system activity and the release of norepinephrine from these ventral hypothalamic neurons that stimulate the sympathetic nervous system, we're going to release norepinephrine, and it interacts with the receptor on these adipocytes, which we call an adrenergic receptor or a beta adrenergic receptor. Are you all okay with that so far? So that's like relatively different information than I presented before. So this beta adrenergic receptor that is now being activated through the sympathetic nervous system is a G protein coupled receptor, which is why you see G protein here. And one of the things that happens is it will activate adenylate cyclase. Here it's called adenylyl cyclase, and I use the terms interchangeably, adenylate cyclase or adenylyl cyclase, and it causes the production of cyclic AMP. And this cyclic AMP in turn, in this adipocyte that's now responding, is going to activate protein kinase A, and protein kinase A will then work on the nucleus to actually increase the transcription and then the translation of the gene UCP, which is uncoupling protein 1. That means that the mitochondria are now going to embed more of this uncoupling protein 1 in the mitochondria. So these adipocytes are being converted. So they're going from white adipocytes into the brown adipocytes, and this is important in heat generation. In fact, some individuals, I've never seen this myself personally, but some of you might know friends or family members. Have you ever seen anyone who, as they start eating, they actually start sweating? I've never seen it personally myself, but anecdotally, like I've heard that some individuals actually start sweating as soon as they start eating, and it's through this pathway that we're seeing here. They're generating heat through this pathway. And one of the things that's important is that in this mitochondria that now has more of this uncoupling protein 1 or UCP1, these mitochondria are really good and very efficient at undergoing beta oxidation. So beta oxidation is a process where we take some of the fatty acids that the adipocyte has stored. So it stores triglycerides, the glycerol groups break off, the fatty acids are released, and these fatty acids undergo beta oxidation in these mitochondria. And the mitochondria are the rate limiting step. You don't have enough mitochondria with enough uncoupling protein. Beta oxidation is at very low levels. And so this is how we generate heat. And so we know that in some very severe forms where we don't have enough leptin signaling, we don't have enough activation of this pathway. In fact, some individuals are very cold, where they don't really generate a lot of thermogenesis. They have an inability to stay warm. And when I ask why, it's through this pathway that is outlined for you here. Now, I just spent the last 3 minutes going over and kind of outlining this pathway. And there are some molecules that I haven't mentioned, like perilipin and others. I really just want you to concentrate and focus on what I've mentioned to you. And if you know that, you will be fine on the 2 multiple choice and 1 short answer question that you'll get on your term test. Are you okay with that? Do you need me to clarify anything? Anything to confirm with any of you as we go on? Yes. Yep, they have more issues generating heat in response to like eating. Yes, they do. They're slightly cooler. Great question. Yes. Yeah, so in adults, it's kind of spread throughout different parts of the body. We're not going to go through that in as much detail. In fact, it can go from subcutaneous and it can just transition to beige to brown. So it's a great question too. And yes, you have a question. Yes. So one of the things that all adipocytes have, so all adipocytes, one of the things that they do is they store triglycerides, right? So they're a storage vesicle, and that's what we used to think in the 1990s, early 2000s, that's all they did. We now know that they release different factors, they're associated with different cell types, but even though they're storing this, they actually don't have the ability to rapidly convert that through beta oxidation. That's all like a mitochondrial-driven process. And one of the key steps in beta oxidation is the production of UCP1. Without that, those mitochondria are not able to really do this efficiently. Okay, no problem. Any other questions, things that you want to confirm before we go on? This is only like half of the story that I'm extending. There's like another part over here because I didn't really go through this in detail, and you need to know some of this for your upcoming term tests as well. My goal, hopefully, is to give you like a pretty clear picture of what the expectations are for your first term test. Term tests are stressful, not stressful? Stressful, kind of, right? For those of you who didn't answer, I'm hoping that it's not so stressful, but I think for most of us, I still remember being an undergrad, they tend to be stressful. And so I wanted to try to mitigate or reduce as much of that stress as possible by letting you know like what to study from these particular slides. So leptin is also signaling here. I've already covered the NPY pathway, and we stop releasing NPY. And without NPY being released, we have no food intake. We don't want to take in any more food without this NPY being present. There's this other pathway that I didn't really talk about. So this other pathway where we are activating a group of neurons within the arcuate nucleus, still in the arcuate nucleus, this is going to cause the release of alpha MSH, melatonin stimulating hormone. And one factor that I haven't talked about is melatonin. If you've been studying, and is there anyone who actually has been studying for term test 1? Oh, okay. Should I be worried? Worried? Should I be scared? Really scared? No. Yes. Oh, I should be. Okay. Okay. Actually, I have nothing to be scared about because I don't actually do the marking. Your TAs are going to be marking, and I don't actually have to worry about this on my transcript, but you do. So, with that in mind, melatonin. I haven't gone back and addressed melatonin. So remember, melatonin levels also determine like food and eating and everything else. This alpha MSH is eventually going to cause the release of melatonin, and melatonin in turn, and this is important because I haven't covered this, melatonin will then interact, and it's not MSH directly, it's melatonin. So melatonin will act on these MC4 and MC3 receptors. So when you see these are melanocorticotropin receptors. So just remember the abbreviation. And one of you were asking, it's a great question, and I'm reminded of this while I'm on the slide, you will get the abbreviations and the long form wherever possible, and on your answers, if there's an abbreviation we've used in class, you're free to use that in your short answers. You don't have to write out the whole word. It will act on the MC4 and MC3 receptors to actually inhibit food intake as well. So that goes back to the melatonin. And now I've introduced you to the melatonin receptors. What does melatonin actually bind to? It binds to these melatonin receptors. There's one other really important part to this. Where are these melatonin receptors found? They're found in the hypothalamus, a totally different subset of neurons. Okay, so just keeping in mind, this is still part of the hypothalamus, and the melatonin is acting on receptors in the hypothalamus. Again, just spent another 2 minutes just talking and not really pausing. Do you have any questions, things that you need to confirm, things that are confusing that you might need explanation on? Yes? Yep, it does. So we're not going to go through the whole pathway. We will later about how we actually get MSH to then cause the release of melatonin, but the melatonin comes back and acts at the level of the hypothalamus. Okay, and that's all I want you to know. It's a great question, and we're going to cover melatonin and MSH, melanocyte stimulating hormone, after the break, and when we talk about skin. Any other questions, things that I can clarify for you? Do you expect questions on that on your term test? Some of you are nodding yes. For those of you who are not nodding yes, you should probably be nodding yes. So this is an important slide, and the extended parts are also important for you as well. And again, think about that for the upcoming review. If you have any questions that you think of between now and Friday, please feel free to ask. So another really important slide, and one that you should make sure that you are aware of, I'm not going to add anything to this slide. It's just to go back and remind you about the different types of macrophages, the immune cells that are associated with different types of adipose tissue, particularly visceral adipose tissue, and how we make this transition from anti-inflammatory adipokines to, as we start expanding the size of these, and as we start undergoing sort of excess intake through diet or through lack of exercise, how we expand and we change some of the physical properties, some of the cellular properties, some of the adipokines that get released. And I told you that we don't need to memorize all of these, things like leptin, resistin, interleukins, tumor necrosis factor. Those are the ones that I wanted you to concentrate on. And then also to know like what happens if it continues and it loses this blood supply. An important slide, and one that I'm putting up here to remind you to study this slide, because you'll get quite a number of questions that relate back to this slide. Okay? Any questions, things that, yes, hello? No, I'm talking about melatonin. Yes. Yeah. So we'll talk about melatonin, melanin, all of those, and we'll talk about those later. All right, so I also talked about some of the different properties, and again, really important that you know that there are differences between the substances that get released from visceral, unlike subcutaneous adipocytes as well. And again, just to kind of frame things for you, whenever you see bullet points, it's a pretty good sign that I've probably gone back over the lecture notes, and I probably used like what's on different bullet points to go back and design some of the different questions that you might have experienced, So we then transitioned into depression, and here it's just a really quick transition. And we talked about the overall impact of depression, and there's nothing on this slide that you should really be memorizing. It's just to give you some context that depression is actually a really disabling condition. In fact, we think about really severe conditions like ischemic heart disease, or we think about pulmonary disorders. Or even Alzheimer's, and yes, they have like great impact, but actually depression has a bigger footprint on your everyday life, and it affects you in your everyday life much more than some of these other things that you see on this list. And again, just for your own information and for some context. And we did talk a little bit about things that are on here that many of you will be directly impacted by depression, even though you might think that I'm good, so I have like a really good support system. I go out and exercise regularly. I take good care of my health. I sleep regularly, so I don't really have to worry. And I'll talk about my own experiences along that way. And it's one of those things that you're never expecting to have like mental health related issues, but you should be aware that it can happen for a variety of different reasons. And it will probably affect you directly or indirectly over the time that you're in university, or even the time that you have left. It's likely going to affect you. So I just wanted to mention a quick abbreviation. So these antidepressant medications, these prescription antidepressant medications, are ones that we're going to start thinking a little bit about over the next few slides. All right, and we talked a little bit about mild depression, and again, sort of a low dark mood. One thing that I emphasized is that a lot of these slides and a lot of the things that you read, if you're in psychology, you might be very familiar with the Diagnostic Statistical Manual, DSM-5. You might hear about like depression usually lasts between like 8 to 12 months.
Dysthymia is about 2 years. These are like not numbers that are set in stone, and you should be aware that these things can last like years. They might never go away. So dysthymia for some individuals is always there for them, and they're always going to be experiencing this. So again, just keeping that sort of context in mind. It is also an interesting thing because we're going to talk about bipolar disorder as well. For those of you who have taken psychology, is bipolar disorder where we have both depression and then we have this other phase which is called mania. So you feel like you're very energetic instead of being like low energy, low mood, like you're in a high mood and you're very energetic, and you go through these different transitions. Is this the same disorder when you're down, or is it completely different? Is the biology the same group of neurons, same impact on the brain, or is it a completely different disorder, do you think? So when you're like in the down phase of manic depression or bipolar disorder as it's known now, like what do you think? Any ideas? Any guesses? Wild speculations? Wild rumors that you want to post on Facebook? Yeah, some very cautious hands. Yes?
I think it might not be the same. That is kind of like it's very like the main aspect of it. So I think it might not be the same as
Okay, so one possibility is like it's a completely different disorder. So the down phase that looks a lot like depression, and depression looks very different for different individuals. And even in the same individual, when they had depression, it may look one way 1 year, and another time that they have it, it might look completely different. So it's a lot like having like the cold. You might have like completely different symptoms. It might be a headache, and then it might be like runny nose and headache a different time, or a cough. So it can look very different. But the thought is, by most psychiatrists, and we'll talk a little bit about this, that many of the same sort of symptoms that are in the down phase, in the period of depression, in this bipolar disorder, probably involve the same groups of neurons and probably involve the same mechanism. They just don't know what causes the other manic phase, the time when they need less sleep, when they start thinking they can do anything, when their thoughts go from one thing to another, they just really can't settle down on one thing, and they start engaging in reckless behavior. They may not need as much sleep anymore. And again, stereotypically, you see this sort of like switching like almost immediately, but these changes can be very gradual, or they can be very sudden depending on the individual. But we're going to be talking about bipolar disorder later, and I wanted to put that in the context that many individuals think that it's similar enough to depression that it should be included with depression. Not everyone agrees, but for the sake of this lecture series, we're going to kind of put that all together. And it is a simplification, so I do have to apologize for that in advance. So when we talk about major depression, usually, not always, but usually it's a sudden onset, and it can be triggered by a lot of different things. Usually it's stress-induced. There's some sort of crisis, lost family member, some sort of trauma. It could be like a lot of different things. You normally are not experiencing depression like when you're walking down the street and everything is going well and you suddenly have depression. Something is usually a trigger for the vast majority of individuals. It is incredibly debilitating. I cannot emphasize that enough. There's really not enough known about depression for most individuals, where you think that, well, they look perfectly fine. Why do they need accommodations, for example? A very common question that many professors have to answer. The simple thing is the mood part is bad enough, so just feeling like you can't do anything, aren't motivated, can barely get to class, and having to sit through class can be like a real chore. You can't concentrate. That's the biggest thing that most people with depression experience. So imagine being a student and you have to memorize things or learn things, but you can't. And that's like the biggest impact that depression has on your age group. Your inability to make good decisions cognitively or remember things cognitively is like the biggest impact. And unfortunately, when we look at major depression, it is possible that you only have one episode, you only have depression once, but it's more likely that once you've had it, you're going to have it again a second time, you're going to have it again a third time. And it's like living with a chronic condition after you've had that first bout. And in some ways, it kind of looks a little bit like shingles. Do you know what shingles is? So if you've ever had chicken pox and you didn't have immunization against the chicken pox, that virus still lives inside the roots of your spinal cord. And whenever you're stressed out and whenever you're feeling really tired, for some individuals, especially when you're tired and your immune system is slightly depressed, that virus can be reactivated and then it travels back along your nerve roots and then you get the same outbreak of chicken pox. The virus is reinfecting your skin cells, but it's actually much more painful. And so that's what major depression is like. You're always kind of living with this knowledge that you might have this second, third, and continuing episodes of depression and this recurrence. And that's why we don't want anyone to have that first incidence of depression. It's one of the things that we're concentrating on really, really hard. If we can stop that first one or we delay that first one, it might be better for everyone involved. So again, this isn't an important slide, so I won't sugarcoat it. You need to know some of the information on here. So there are two different approaches to understanding depression. One is that we can just look at it sort of through the psychology, so the Diagnostic Statistical Manual, DSM-5 or DSM-4, which is the version that I'm most familiar with. We can also look at it as biological. So if we look at how the National Institutes of Mental Health look at some of the features of depression, usually the median age of onset, so the median age, it's not like the entire age range, so 15 to 44 is the most common, but if you look at the median age range where like 50% of individuals, it's about 30 years of age. It doesn't mean that you can't have it when you're 22, so many individuals will have it in university, but the median age for the general population is about 30 years. It does affect females still more to this day than it does males. Depending on what source you're reading, it can be like 3-to-1 ratio or it can be a 2-to-1 ratio, but it has been shown consistently that females are much more affected than males. If I were to ask you, most of you would identify that depression is likely a neurochemical imbalance because when you get treated for depression, often you are put on antidepressant medications that will restore some of the neurotransmitters. So you've all heard of the neurochemical theory of depression, right? Your neurotransmitters go down. Have you heard of that? And you take drugs that increase neurotransmitters in your brain again and everything is okay for you. So that's the theory. Is that new for anyone? Hopefully not. I mean, it's kind of common knowledge, I'm hoping. So these are the most common types of neurotransmitters that are believed to be affected within depression. So we have a loss of serotonin signaling, or we have a decrease in noradrenaline, or both, so serotonin and noradrenaline, or you might have alterations in dopamine, and these are all known as neuromodulators or monoamines. That's how we characterize them. And it's thought that when you're depressed, all of these neurotransmitters, and in particular serotonin, that I'm going to be spending more time on, lead to the cognitive impacts of depression. This lack of energy, lack of motivation through dopamine and noradrenaline, and your inability to concentrate, that lack of serotonin. And again, it's a brilliant theory because it describes what we know about the neurotransmitters, but it's completely wrong, right? So I'll talk a little bit about that. And if you think about this, how does a sudden stressor cause you to suddenly lose like your neurotransmitter levels? Like, have you thought about that? Like, how does that work? And why does that work? So biologists have not been really happy with this theory, and we're going to look at one potential theory in a moment. So before I go on, do you have any questions or anything that you want to confirm, go back over, or discuss before we move on? Anything at all? Yes? So I'm going to address that in a couple of ways. So one, in terms of biology, you can get a brain scan and there's 100%, like every brain scan, if you're depressed, you're able to show that you have a decrease in neurotransmitters, you have a decrease in many of these systems, especially serotonin. So that's actually well described. How that happens, why that happens, is not clear. How these antidepressant medications work is also not clear. So that's the missing link. But it is a neurochemical imbalance. How you regain that balance is not clear. What causes that imbalance in the first place, also not clear. Any other questions? No. I'm hoping by the end of today's lectures, and there's still a lot of ground to cover, that you're going to understand why serotonin is one of these key players that I've kind of outlined for you here. So I'm also just mentioning as well, this upcoming, tomorrow is actually this year, the Bell Let's Talk sort of thing that's happening. I'm hoping that many of you will take part in it. There's a lot of controversy around it. I still think that normalizing the discussion, just being comfortable discussing like mental health and reducing the stigma is an incredibly important part to this. As many of you know, I've had depression twice in the time that I've been here at U of T while I've been teaching. They are very different experiences for me. So the first time I had it, I just didn't know what it was. The second time I had it was much more severe. And as a result, I always go in now for like, before the start of the fall semester, I always get a physical checkup. I get blood drawn to make sure that there isn't sort of a hormonal imbalance. I'm not missing vitamin D, that anything that biologically could cause issues, like I get checked for that. And some years, for example, one particular year back in 2017, I was actually told that you are probably going to have some issues this year, and it happened, and it was exactly that case. Like I knew ahead of time, like I had failed my physical checkup, some of my blood work came back, and I had like a very bad bout of depression that lasted for a significant length of time that particular year. I still proactively and in terms of worrying about having another bout of depression, since I've already had two, I usually take antidepressant meds, but as I've also mentioned, some of these antidepressant meds have some pretty unenjoyable side effects. So the ones that I take currently have caused a little bit of weight gain that I can't really easily get rid of, and I also have a little bit of problems concentrating. So those are things and reasons why I stopped taking them. May not have been the best idea because we're getting into a really stressful time. It's stressful for you. It's stressful for your boss as well. So just again to keep a couple of things in mind. So with that in mind, let me just mention a couple of things on this particular slide that cover also like the next slide as well. I want you to, one, feel really comfortable talking about mental health. If there's something bothering you, if you're not feeling well, go see your doctor first. And if you want to talk about like what's going on, feel free to talk to either myself, your TAs, particularly like Amanda, Tal. They're actually trained to talk to students about mental health related issues. And I'm happy to talk about my experience with you at any point in time. I'm not embarrassed or ashamed of it. Those things happen. And I also feel like if you want to talk about it, you should feel free and comfortable doing that at any point in time as well. Right now, we don't really have a good marker for major depressive disorder. Like, it's just like getting a concussion. You can't go in and get a scan like, oh, you're concussed. We don't know. Your brain is one of these tissues that are really hard to get a clear picture of like a reduction in neurotransmitters. You had asked earlier, one of your colleagues had asked earlier, so does your serotonin go down? It does, but it doesn't go down to the extent where you're like, oh, half of it's gone. So it might go down like 10%, might go down even less. It does go down, but you need to have like a baseline reading of like serotonin levels normally. That means you're going to get a radioactive tracer put into your body. And how many of you have had that done? Like you've had like a radioactive label put into your bloodstream and you've gone in and gotten a PET scan. Some of you in psychology might have done that as part of like a study, but it's unusual for you to have like baseline values for serotonin or other things. So one of the things that has been clear is that there is a marker protein that we can detect in an intact individual without opening up the brain that might be a good diagnostic feature, which is known as TSPO or translocator protein. And this might be a way to go in to see if you have major depression, how much of this marker that you have. This marker, by the way, is also a marker for inflammation. So again, just putting that out there as well. Now this next slide And can I, Mystica, do you know if this thing is still streaming? Because it's slowing down slowly. I'm hoping it's still working, but hopefully it's all good. Okay, thank you for doing that. So one of these markers is TSPO. And TSPO here, if we're taking a look, the brighter the red colors are, or the more red color there is, the more of this marker TSPO that there is. And one of the things that you're going to see is if you have depression and you are not on antidepressant medication, there is a lot of this TSPO around. And this TSPO is that translocator protein. And if you were to make a guess, what cell type do you think that this marks? And you're going to have to do a little bit of writing. You're going to have to know a little bit about what I'm going to be showing you on this slide. So TSPO is a marker for inflammation that is associated with depression. We can see this on a PET scan, and we inject you with a radioactive label that then binds to TSPO within certain cells within your brain. What cell type do you think it is? What cell types do you know in the brain? Well, there's one that you must know, like, it's a given. Neurons, right? So it could be neurons. What other cell types are up in the brain? I don't know what that means, but it's a myelin. Okay, so maybe oligodendrocytes? Maybe. There's another cell type. Do you remember what the immune cells in the brain are called? They have a special name. Microglial cells, so that's a possibility. And we're dealing with inflammation, so these different cell types. So just to kind of get right to the point, TSPO is a mitochondrial protein. So what else might we see associated with TSPO? What other mitochondrial protein did we talk about today? UCP1, so mitochondrial marker. In adipocytes, here, mitochondrial marker that is particularly important and activated in microglial cells. So these microglial cells respond to inflammation, and we can mark these microglial cells in red using a radioactive dye that binds to TSPO, which is what we're seeing here. And the take-home message from this is a simple one, but also an important one. And you don't need to really write anything down about this, but one thing that I really strongly suggest to you, so if you know that you're sick, would you delay going to see the doctor? To be honest, some of you will, right? Like life happens, you got to go to school. Like I'm going to see the doctor like next week. But if you suspect you have some kind of mental health related issue, you should go see someone like right away. The longer you leave it untreated, where you're not sure what's going on, just don't feel like yourself. Just feel less energetic. If you leave it untreated, the longer you leave it untreated, the worse off your outcome is, and the longer you're going to have to be on treatment. So there's nothing wrong to go in and just talk to someone. So I'm just trying to emphasize that to you. And the duration of this untreated illness is one outcome of this study that was really clear. The more of this red that they saw in an untreated illness, the longer it took for that individual to recover. The problem is most of you will never know what depression feels like because you've never encountered it before. And the first time I had depression, I just felt like I wasn't really sure what was going on. And I left it untreated for probably a good 2 or 3 months because I simply didn't know. And that's not good. Nowadays, like as soon as I feel like a little bit tired, I'll make an appointment to see someone to make sure that it isn't something more drastic. So if we look at when you get depression, so do you remember, without looking back in your notes, let's see how good your short-term / long-term memory is because it's almost getting to the hour point. What is the median age of onset for depression? 30 years of age. So if you're in the latter part of that, so remember 15 to 44, median age is smack dab in the middle. So in the latter part of that, if you're at 44 to 45 years of age, so you're in late life, midlife, late life, the bad part of getting depression late, so like you've been okay throughout your 15s, your teens, your 20s, your 30s, you passed the median point, nothing has happened to you. The bad part of getting depression late in life is that it actually increases your risk of developing dementia. So again, getting treated early and making sure that you're aware of what's happening is like really, really important. Depression does matter. It matters like on so many different levels that I can't begin to tell you. We don't want it at your young age, but we also don't want you to get it when you're older because it actually increases your risk of developing like dementia. So, and you all know dementia, dementia and Alzheimer's disease. Those are kind of interrelated. This marker for inflammation, just as a reminder, for us, we look at C-reactive peptide. It's one of the things that you can get from your blood. So I always get tested for inflammatory markers like C-reactive peptide just to make sure that my inflammation baseline levels are fairly normal. So I'm going to take you through a couple of really quick slides with Dr. McIntyre. Some of the slides are things that he would normally talk to you about. Some of you will go and shadow with Dr. McIntyre. And he's a psychiatrist who kind of looks at some of the different aspects of metabolism and how it relates back to mood, and particularly depression and bipolar disorder. And so some of the things that he's worried about or interested in right now is, does it really involve those neurotransmitter systems like serotonin, dopamine, noradrenaline, those monoamines? Does it involve like changes to how neurons receive neurotrophic factors? Does it kill neurons? Are neurons susceptible to damage? And we'll talk a little bit about this. And how does the inflammatory system kind of trigger all these changes in all these other systems up here? And this is sort of a slide that I'm using to transition into some of the more interesting things that he sort of looked at. So one of the things that we've looked at before early on is that if we look at BMI, an imperfect marker for health status, and if we look at BMI and we are normalizing BMI, which is what Z scores are. So let's imagine like the perfect BMI where you're a healthy individual. So around 24.9, so you'd be right here, no health-related issues. And if you're under that normal healthy BMI and you're into the cachexia, sort of the underrepresented BMI, we're into the negative numbers. And if your BMI is higher, then you're into these positive numbers. And we're just normalizing it for a Z score instead of using the actual BMI numbers. One of the things that we can look at is this cognitive score, this CS score. And we can see if there's a correlation between your BMI and what happens to your cognition. And one of the things that has been known for a while, as you increase your BMI, so as we go along this axis here, and you might have an underlying health-related issue, there is a correlation. So in fact, there's a correlation where you have a reduction. So the lower you go, your cognitive score, your ability to remember like 10 different things, you can't remember 10. You can remember 8, or you can remember 6. You're going down. Your score is going down. Your BMI is increasing on the x-axis. Your cognitive score goes down. So there is a link between cognitive score and BMI. And this goes back, maybe these things are related. And that's the major take-home message here. Your BMI scores are in fact related to your cognitive scores. Is that clear for everyone? You do not have to worry about individual data points. Just a take-home message from this slide that there's a correlation. As you increase BMI, you are actually going to decrease cognitive score. Clear on that? That's the only thing that you need to know. Not clear. If you're not clear, just blink hard really, really strong right now. No blinking. Okay, I'm assuming you're good. All right, so a couple of other things. We talked about type 2 diabetes, kind of one of those things that are related to metabolic syndrome. And if we were to take a look, again, these are all normalized for Z scores. And if we are looking at individuals, control individuals, and these are older individuals, by the way, so they're sort of in their 50s, 55-ish age range, so they're all age matched. One of the things that you would see is that the information processing for individuals that have like type 2 diabetes is actually low to begin with, lower than the baseline. Their cognitive processing is down. So again, related to metabolic syndrome. BMI is related to metabolic syndrome, that previous slide, this slide here. And if you follow them up 4 years later, their cognitive processing speed also goes down. So cognition is definitely going down related to metabolic syndrome and BMI as we've looked at before. So attention and executive functioning also is age-related. So there's an age-related decline, and this age-related decline is also there for type 2 diabetes as well. So decision-making, being able to pay attention, these are also affected with age as well as with type 2 diabetes. But pure cognitive skills, it seems to be much more associated with diabetes, okay, or metabolic syndrome. Clear on this slide? Anything that you're not clear about? And again, if you think of questions in the intervening time, please let me know, because we'll come back and we'll do this during the review session. Okay, so we can do this a couple of different ways. So I still have about 3 or 4 slides to get through really quickly. So we can either do that and then take a break, or we can take a break and then come back. Do you have a preference? Keep going? Okay, so if you're okay, we'll keep going, finish this, take a break, and then come back. Oh, is it just because Omar was the loudest and I heard him and not? Okay, Omar. Okay, all right. So shall we listen to Omar or not listen to Omar? Okay. Hey, Omar. You're an influencer. How about that? Okay. So I just have a few more slides to get through, and these are important slides. So I don't need you to memorize this pathway, so that's the first thing. But this is really important, so I do want you to highlight a few things. So there's this one molecule that we're going to come back to several times, IDO. So IDO is this key enzyme that I'm going to show you again on the next few slides. And one of the things that's really important is that IDO, if it's active, it actually prevents the formation of serotonin. So tryptophan can go into 2 different pathways. One can actually form serotonin. Remember serotonin? Remember depression? It goes down. So tryptophan is an amino acid that normally forms serotonin. Serotonin is normally then broken down after it's been used as a neurotransmitter into this breakdown product, which is known as 5-HIAA. You do need to know that as a breakdown product for serotonin. Do you know why, by any chance? Like, why do we talk about this? Do we ever measure this in your bloodstream? This molecule here? It's a 50-50 question, folks. Yes, no? Take a guess. Yes. In fact, good guess. Awesome. So why do we measure the breakdown product of serotonin in your bloodstream? Isn't it all up here in your brain? Why do we measure this? Any ideas? Yes. A lot of serotonin has been broken down, but it's in your bloodstream. Normally it doesn't go back across your blood-brain barrier. So there's this really cool thing that we're going to talk about later. Tumors, as tumors start growing, they actually secrete a lot of serotonin. So 5-HIAA, the breakdown product, if you find a lot of that peripherally in your blood, this is a test for tumors. And we'll talk a little bit about tumors and how they secrete serotonin, why tumors secrete serotonin, and why this marker for the breakdown product of serotonin as a tumor marker is important. So you do need to know that, by the way. So if you have any questions, please let me know. This is a tumor marker. For those of you at home or for those of you who come back, this is an important key molecule. And this pathway is actually not just in the brain for neurotransmission, but also really important for tumor biology as well. However, this is the normal pathway that we'd like. If we have IDO being expressed, or we have a lot of IDO, and this indolamine, which I'll talk about, causes the formation of kynurenine. This kynurenine is important because eventually it can be broken down into quinolinic acid. So this molecule here, you don't have to worry about any of these intervening steps. So kynurenine forms quinolinic acid because we have more of this IDO, and this quinolinic acid is believed to induce neurotoxicity. It causes reactive oxygen species to form. It's bad for neurons. So normally neurons are happy forming this pathway, but for some reason we've induced in these neurons IDO. It forms this molecule instead, kynurenine, and this kynurenine can then form a neurotoxic compound. And that's why this is bad. And this is why, for example, it might go down in depression and this might account for some of the biology. So this is an important slide. I won't lie. You probably will have it both in your short answer as well as within like the one-line answers as well. Okay, so do you have any questions on this before we get going? Just a couple more slides, then we'll take a break. So this again is also going back to one of those neurotransmitters that we talked about earlier. And there's just a couple of really key simple ideas. Hopefully it's a review that you've had in some of your other first year classes. Maybe if you haven't, all good, we'll talk about this now. Healthy individual, normal BMI in other words. So again, a little bit of a hint. You might have a clinical situation where you have to kind of look at a BMI, look at some different blood values, kind of make a call like, is this a healthy or an unhealthy individual? And then you might have to kind of expand a little bit on that. So they have normal insulin receptor signaling. Fantastic, because that's what we want, normal insulin receptor signaling. And then this causes an increase in mitochondrial activity in a healthy way, and it actually inhibits oxidative stress within the brain. And so it actually enhances dopamine signaling. This is what happens under normal conditions. And in fact, we also inhibit the activity of two enzymes in the brain, MAO and MAOB, that break down dopamine. And so this enhances dopamine signaling, which means that you have improved mood, etc. However, if you have metabolic syndrome or you have insulin resistance, your brain also becomes insulin resistant. And here, this insulin resistance causes MAO and MAOA, or monoamine oxidase enzyme A and monoamine oxidase enzyme B, their activity goes up. Mitochondrial activity, on the other hand, goes down. The normal protective mitochondrial activity goes down. We increase oxidative stress, and that means because we have MAOA going up, we have more oxidative stress, there's less and less dopamine. It's being broken down faster and we have less dopamine. And this might lead to a reduction in dopamine that causes anxiety as well as depression. So whether it's serotonin or whether it is dopamine, there is a biology that's associated with it that is linked to metabolic syndrome. So really, really busy slide, which you don't have to know at all. I'm just going to emphasize a couple of things here, and I'm going to link a couple of things together. And apologies, I just slipped through this one slide. Questions before I go on? Any confirmation, questions, unclearness? Yes?
I have a question about the previous slide, actually.
Okay.
Are we going to go over what causes the pathway
For this pathway to go?
instead of serotonin?
Yes, it's actually on the slide that I was just going to get to. Any other questions? I won't go through the detailed mechanisms, which is like fascinating in and of itself, but I'll talk about that really briefly. One thing that we know is that the activator of IDO in the brain are these pro-inflammatory cytokines. So if you have like metabolic syndrome or you have inflammation going on, it actually activates and turns on IDO. So that's the one key link that I haven't talked about. So what might turn on IDO? Things like interleukin-1, TNF-alpha, interleukin-6. All of those things would be an activator and turn on more of this IDO. Normally we don't have that, and normally we don't have inflammation in the brain. But suddenly, if you have metabolic syndrome and your adipocytes are now producing more of this, and these cytokines are there in high enough numbers, IDO is going to be turned on. None of these other pathways, which I've talked about, are ones that you need to worry about. Okay, it's just to make that link with this pro-inflammatory cytokine. That's the only thing that I want you to take away. This top part of this diagram, if you want to line up the rest of it, it's all there, it's all the same. You don't need to know any of the details on any of the bottom part of this. If you're curious about what the name of IDO is, this is the full name. I don't expect you to write that out if you were asked, but this is the enzyme that converts tryptophan into kynurenine, okay? On that previous slide. I don't know if that addressed your question from earlier, I'm hoping. Okay. All right, so getting pretty close. So do you remember this molecule, C-reactive peptide? What is a marker for? Inflammation. We can measure it in the blood. And so this is just, again, to show you that there's a relationship between having low levels of CRP. And if you have low levels, therefore low inflammation in your brain, most of your brain is functionally connected to other areas of your brain. Your frontal cortex, again, these are not important because this is not a neuroanatomy class. Low inflammatory status means that the functional connections between different areas of your brain, you have lots of connections. Your brain is working as a synesthetic unit, so it's working together all at once. The more inflammation you have, so you have like mid-level CRP, you have high levels of TRP, you have less and less functional connectivity. The frontal area of your brain that makes executive decisions is not as well connected as it is in an individual that has low levels of CRP. So this is the only thing that I'm trying to get across. Inflammatory cytokines, CRP that we can measure as a marker for inflammation, they're inversely correlated to the connectivity of the brain as a whole. And again, you don't need to worry about all of the different areas of the brain that are interconnected that we can go in and measure. This is more for your own sort of review information about how we might introduce inflammatory cytokines and how we measure CRP levels in the brain. You don't have to worry about anything on this part of the diagram at all, nor do you have to memorize any of these values. It's just the overall big picture from this slide. Any questions? Things to confirm? No? All right, so again, I'm not going to hold you to any of these things here, just to show you if we do what's known as a meta-analysis in bipolar disorder, which we're kind of linking with depression, if you have more of this C-reactive protein, it actually is a good marker that you will have bipolar disorder. And that's the major sort of meta-analysis that you're taking away from all of this. The overall effect is shown down here. I know some of you have had this with me in other courses. Again, it's just big picture. C-reactive protein increase, more of a likelihood of developing bipolar disorder. And again, this is just another thing showing that if you have bipolar disorder individuals, that if you're looking at inflammation within the brain, they always have like more inflammation than individuals who are age-matched healthy controls. Again, nothing new here either. And inflammation, social cognition. When I say social cognition, there's a difference between being able to remember like 10 different numbers or to be able to put a story in order, like your cognitive thinking. What is social cognition? Any ideas? So you can clearly see that in individuals that have been injected with like an endotoxin, so you induce inflammation, they actually have a reduction in social cognition. What does that mean? Any ideas? Any guesses? Random guesses? Funny guesses, like completely funny, make your prof laugh. Haha. Yes. Social cues, exactly. So if you're like really tired or if you're like sick, you're not going to pick up on social cues like, hey, that person looks like they're really upset with me. If you're sick or you have inflammatory status or whatever's going on, your social cue recognition is down. So again, just showing you, and that's often the case within depression and bipolar disorder as well. So we can induce inflammation using like an injection of endotoxin, often done, by the way, on nice, healthy university-age students because you're always looking for money. So when you volunteer to go into the psych lab and they inject you with something, and it's just nice and normal. It's a normal experiment, and you can recover fairly quickly. But these are often done there as well. We won't worry about this drug, and we'll skip this slide just for the sake of time. And I just wanted to show this because this is one of the molecules that you have learned before. Do you remember this molecule at all? Adiponectin? Do you remember what's special about adiponectin, like at all? So I can tell you're trying to remember it because you're all kind of looking down. So that's good. Yes. So one of the things that it does is it increases insulin sensitivity. Usually there's an inverse relationship that we talked about with like metabolic syndrome. And one of the things that you see here is that this new drug, which is known as ketamine, adiponectin is a potential marker for like depression. So we might be able to measure adiponectin but more importantly, it might also tell us a little bit about the responsiveness and how well an individual will respond to different treatments. And again, we'll kind of just stop there. The last thing that I'm going to mention is this one slide. I don't know if you're aware of this or not. Cognitive behavioral therapy is also anti-inflammatory. It actually reduces your different cytokines. So if we were to take a look at cytokines like TNF alpha after cognitive behavioral therapy or interleukin 6, just talk therapy, being able to talk while you have depression actually reduces cytokines like interleukin 6 and TNF alpha as well. It is a specific result because if you look at other forms of therapy, they don't cause the same reduction in cytokines. Okay, I think that's it. We're going to take a break now. None of the other slides that are remaining, you don't need to worry about them. And we will come back from break. And then when we come back from break, you'll get some prompts for the Kahoot. And then we'll kind of wrap things up in terms of getting you ready for your first term test. So let's take a good 10-minute break. We'll get set up in the interim. And please stick around for the second half. So, Mystica, is it all still streaming?
Yes, it is.
All right.
Do you want us to stop streaming? Or
Nope.
I think we can
No.
physically the stream.
Yeah, so we're just going to be on a different screen.
Yeah.
So one of the things that we can do, so we can just leave this. In fact, we'll go here.
Okay.
This will be on there, and we can just use this. We'll set up. Okay, bizarre. All right.
Oh yeah. I forgot
Okay,
about
so
Yeah. HMB322 Winter 2020.
okay, so I don't know what browser you want to use. Go ahead and use whatever browser works for you.
I feel like I should come up too because like I wrote so
Yeah.
finely.
Yeah, don't worry.
I'll just
You could just. Ooh, where's the mouse?
This
This.
trackpad, if you can use this sort of as a right
I love how I
button
didn't
to
see
hold
that.
things in.
Okay, cool. Love that I didn't see that.
Wait, why are we not doing it on here?
We can do it on. We're just using a different screen. We'll just start with the projector later.
I still have some things to talk to you about. There.
Oh, I see. Okay. So we're not doing right after.
That's just, I hate that we're on Internet Explorer. Like, it makes me want to die.
You know.
I know. That's why I was just like looking for Chrome. Oh, we should. Oh gosh, seriously? They don't even have Chrome on this computer? Okay, whatever. We're using Internet Explorer. Come on, you can do it. Oh, I hate Internet Explorer.
Makes learning fast. Honestly, this website is not well done. Even to be fair, I understand.
Yeah. Okay, so it's HMB322 Winter 2020 at gmail.com. I just logged in with Google and then it just popped up, so the password and everything. Oh, thank God. No, I do not want to buy it. Thanks, maybe. Oh, thank God. It works. We're good. Does this have sound?
Does it?
Yeah.
it's always fun.
Oh, I love the sound. The sound's the best thing ever.
The sounds and like after the question it's all like
You can like adjust the sound.
Yes. I also need to. Can you give me my PSP? This is my job, but
You're honestly doing everything. I don't know why.
I appreciate the support. If I was here alone, I'd be panicking. I appreciate human support with me. Because I can't do things by myself. I need somebody to stand there next to me. I don't know where to plug this in.
Yes.
Oh, please, please. Okay, it works. Oh, this is me being extra.
Oh, you're thing again.
Ugh, I really hate that I'm doing this now.
What groups are you in? You think you're part of something yet?
I shouldn't be. I know it's stupid.
No, it's great.
It's not great. I'm overwhelmed. I'm actually only part of like 3 clubs. Don't record. Okay, now I have to figure out what the hell I'm saying. Don't read for me now.
Are you balancing something too?
Yeah, I'm just extra. That's just me. You should probably.
Wait, what is it? Tell me about
It's a leadership conference. We're having a bunch of representatives come in, as well as a bunch of panels. It's
Wait, so okay, so that's ready to go. Okay, I have a couple of other things too. So your Kahoot's ready to go. It's on a different tab, right?
yes.
Yeah.
We're all good. We're ready.
Okay, not quite. So I'm gonna post one thing as well. If I
You
can.
can
Is there
just
another
exit.
tab?
That's just in full screen. You can just exit. It's just on PowerPoint, so
Oh,
you can do
okay.
whatever.
Wait, but you guys have like something open in terms of.
It's just on. I just have to click play. That's
Okay, but can I get another tab? So
Yep.
I can, all right, so this will work, I think.
Okay.
So I have just a couple of other survey questions.
Okay.
So it'll just get everyone's phones out anyways. And then we'll set up your Kahoot. I still have a lot of time.
Yeah.
So yeah. Okay.
Do what
Let
you
me-
need to do.
Okay. So just give me a quick second.
Oh god, they won't let me do it in Concord. Really? No, they're just like, the only cornhole class in is DSL, and they're like, no, we don't let non-DSL thing.
Really? Did they say that?
Yeah, like I messaged Dr. Customer, and then he's like, I have to forward this to them like for our head, and they're like, yeah, no, we don't allow non-DSL things to be announced.
Really?
Yeah, so they're like, put it in the fun things to do tab.
Every time I like volunteer
I wasn't allowed to, so thank God I didn't have to. But saying that, we should probably announce it in the classes since this is the living and working in there.
You could ask them if they put in like a slide.
Alright, so Mr. Gunn, I'm gonna ask you to get back to your PowerPoint thing, do that presentation and announcement first,
Okay.
and then bring me back here.
Yeah.
Then we'll get them set up, and then we'll see what happens after that. How exciting is that? Okay.
Okay, that's
Alright.
fine. We can do that in a bit.
I'm just gonna leave the microphone here, so in case anyone's actually watching, I don't know if anyone's online.
We're not doing much emceeing. We're really just like reading the questions off, and then it's really like,
Okay. So can you get back to your PowerPoint somehow? Or anything?
oh yeah, I could just.
It should be, unless you guys have done something magical.
What is this one?
Well, I just have
He
that on.
did it here. It's just this funny little slide video.
So this is MPC. This
Yeah.
is now this. So it should be this one.
Yes.
So this is also good to know because in the worst case scenario, you can actually record using this program that's sitting on
Oh,
this.
okay, nice.
All right, it's all yours.
Okay, I'll fart. I don't want
Is it Kahoot phone?
Let's go. You can do it.
Yeah. Oh, do you know how to get volume on this?
Volume on this.
Yeah. No, because the Kahoot itself plays music.
I think it's just.
Yeah, we can do that. So it will be source volume.
Okay, good.
That's this source. So yeah. plays music.
Yeah, it's
It plays
really
like
fun.
music and sound effects. Like when the question ends.
Robert,
like,
is that a good idea?
Yeah.
It's a quality idea.
It's like it's like a nostalgic feel.
Everybody loves it.
All right, folks, we're gonna get going. Before we get going, there's a really important announcement if you're interested in an upcoming event in February. So, Mystica.
Hi everyone, I'm part of the University of Toronto Women's Association, and we're holding a leadership conference on February 29th, running from 9 to 5 at the Hyatt Regency Hotel. It's sponsored by Accenture and Capital One, as well as we're having reps come in from Sick Kids and UHN Research. You're going to be able to meet representatives from over 20 plus enterprises, as well as participate in 3 panels. So the Women in Leadership, Leadership in Color, and Successful Allyship, as well as 6 different workshops, and engage in roundtable mentorship. So tickets are on sale right now at the link above, and a 3-course meal will be provided along with goodie bags. So I hope to see you guys there. Thank you. So your thing? Yeah. I don't know what to do.
You can just go to present. Great, so we're gonna get going with Kahoot in a second. So just to get you ready a little bit, if you have like a Wi-Fi enabled device, I just wanna know how you're all kind of doing. So if you can go to menti.com, and then if you can type in this code, you should be able to give a response back on here. And I'd just like to know how you're all feeling right before term test 1. All right. All right, we'll wait just about another 20 seconds or so to see how many respondents we have like in the class here today, just to see how everyone's doing. So everyone's a little bit tired, makes a lot of sense. So hopefully you're spending some time on the weekend to recover a little bit or sleep in that extra hour that you might be kind of avoiding right now. So hopefully you're all in good shape. Alright, so let's say like a quick 30 way to know what class attendance is like.
Oh,
Yeah, it tells me like how many people.
okay. That's fun.
Yes, I use very devious ways to kind of figure out how many people are there. People wonder like how many people. 120. Alright.
I know, how do you know?
If I don't come to class, it was my whole weekend. Take grades. 'Cause you just
Alright,
catch
so
up.
on that same note,
Yeah.
how ready right now, as of this moment, do you feel like you're ready for term test 1? So are you like completely not ready? Then you like low numbers? Ooh, 2.3. It's like the GPA. Okay. Ooh. Don't go there. Didn't like that one. Okay, don't go there. All right. Okay. So about a 2.4. All right. We have lots of time to get you ready. Today's where we begin to get you ready a little bit for your upcoming term test. All right. So I think that's more or less everyone.
I feel like this.
And if you can answer this one fairly seriously, it's all confidential. I don't actually know who's like responding. So like, how are you feeling in terms of your mental wellness? I just want to do a little check-in. As I was mentioning before, and Amanda's at the back, and she deals a lot with like mental health, and she'll talk about like her research. And I know many of you are interested in like shadowing, potentially seeing what Amanda does. But we are like very committed to like making sure that we are responding to your mental wellness, and it's important to us, and we want to make sure that all of you feel like you can talk about these things and feel like you're supported at any given time. Okay, All right, so thanks for the feedback and thanks for taking part in this. I think we're going to, latecomer. Okay, awesome. So I think here at this point, because I've never done this, I think you're going to get some instructions from Mystica and from Julia and from Robert, I think, right? All of you will be emceeing. And yeah, here we go.
Okay, fine. 2 more to classic. Okay, what was it? Kimon? Okay. Let me.
So,
Then like everyone has to connect.
Okay. Okay, everyone, if you could go to kahoot.it, the website up there, and put in the game pin.
Find a teammate.
Yeah, everybody get in pairs or in groups of 3. Pairs or groups of 3, please. This is so nostalgic. Like, this is 5th grade me.
Never done
This is like late elementary school.
I used to be like, oh my, oh god, I'm sorry. Oh my god, so scared. Oh, you just. But I think. Okay, this is fantastic. Gallstones. The music, nostalgia. Stressful.
I like the sound effects.
That's not you?
Are you participating as well?
Well, wait until a couple more. It doesn't look like it's changed. Oh, it is. Oh, God.
Ask people to like put their
They don't need to put their work in.
ask if they need to put their hands up.
Who still needs time to get in? Anybody need more time to get in? Oh, God.
Should we start? Yeah? Okay.
Okay.
Actually, no one's printed.
Thumbs up if we're ready to start. Thumbs up if we're ready to start. Good. Okay. Does everybody know how to play Kahoot? If not, generally how it is just a multiple choice question. They'll pop up on screen, and you can just choose the answer within your team. It's too loud. Is it anxiety inducing? Everybody good to start? Okay. We're going to start off with an easy question. So who is your prof in HMB322?
Oh, there's 61. Yeah. Wow.
Correct answer was Dr. Ju, if anybody was wondering. Okay. Oh, that's cute. Okay, if someone has type 2 body type, what other term can you use to describe their body? I know, it's
It's making me like, it's like making me anxious.
like I need the music there.
Otherwise, this awkward scene.
Okay, so just going over this, if anybody remembers that list of the different types of body types for type 2, the most correct term would be android or trunk.
Need to know it.
You need to know it. Oh wow, smiley face is running. Okay, what mouse model has a mutation in its leptin receptors? This team talk is really awkward.
Oh, is that what's this for?
Yeah. So you can talk with your team.
It's like you're gonna talk.
Okay, so the correct answer was DB mice. A few of you put OBOB mice. So OBOB mice have a problem with leptin, like leptin creation, whereas DB has a problem with receptors. Oh wow! Look at you. What does leptin do in our bodies?
I feel like I might have made my questions like too hard or too long. But I increased the time.
Okay, I feel like this is easy.
I
Can we
don't
just
want
like
to do it,
skip?
flat.
Okay, so the answer is that it inhibits feeding. Smiley face is killing it. I'm sorry, I didn't read that loud. Simone is suspected of having cachexia, which also observed by so. Would you like to say it though? Okay, I don't think you need to. Okay, I
We
really.
don't need to read them. We should explain what they can see.
I was under like high key stress because I didn't even know what the answer was for some of these questions.
Oh, when I was
I
making
double-checked, like-
the options, I had to like really make sure that I didn't want to be like really contracted my words.
Oh. Should we go through this? Is this too high of a...
You need to know it.
Dr. Drew says you need to know this. Please remember this. Okay, so it's pulmonary problems. Okay, this is a little long one. Everybody's just panicking.
It's at the top. Yeah,
You guys have a minute, so take your time.
I put a lot of time. I know this was kind of
Okay, no, stop doing like this. Let's make sure that the numbers are right.
I did like.
sorry. I've been like explained.
Yeah. We can set it for different times. So like this has 1 minute on it, whereas the other ones have 20 seconds.
Good. Okay, so wow. Okay, so I wrote that question. So obviously it's not hypoglycemia. His blood sugar was 120. That's really high. Type 1 diabetes. There's nothing in the question that would suggest that directly. Insulin resistance, yeah, because if you remember, there was a slide where you divide the concentration of triglycerides by HDL, and if it's over 3, then that'll give you like a sense of insulin resistance. So if you did that, it would give you 5, which means insulin resistance. And then severe central obesity, there's nothing really to suggest that. Yeah.
So I decided to make a question similar to this on your term test one. So it's actually a pretty good indicator. Like you should know.
Hint, hint, wink, wink. Oh, look at smiley face. The smiley face.
Wait. I thought it was counting down.
I know.
It said 3, 2, 1. I'm like, I set the timer to like 3 seconds.
Some of these like trip me up. Like I was looking at them like, hold up, no. They're like disappointing.
That's why I feel like learn everything has
Yeah.
Oh god.
Okay, so I'm not sure if I got something wrong or if you guys got something wrong, but I don't know. Dr. Ju, is something wrong with this? I don't think so.
Couple of things. I told you that you don't really have to memorize a lot of numbers, but you do have to memorize ratios of different things. And you do have to know the blood glucose levels. So that might be the reason why it's kind of all over.
Okay, so I included a lot of numbers, but LDL wasn't mentioned like anywhere in any of the slides, so oops. Okay, moving on.
I know. Oh, damn. I just
That
kicked
really
people off the
shit this
charts.
class.
Kicked people off the charts. Music is weird, so it's probably like anxiety.
Oh, I just realized the phase PI3K is the K at findings.
Good job. I just put it there because
Okay. Oh, okay. So
I did.
because I wasn't, I
I know
actually,
you put PI3 and I'm like K and I'm like, this is the K. And then I'm like, oh, it's
yeah. Good.
Oh,
Okay, so that question was a lot better. Thanks. So obviously PI3K, that's what happens like downstream of the insulin receptor, and then it launches a thing where GLUT4 is made and put on the cell membrane for fat and muscle. It has nothing to do with insulin binding. Yeah, it has nothing to do with the other ones other than that, basically. Okay, good. So yeah, hyperglycemia causes atherosclerosis, which is the stiffening or hardening of your blood vessels. It would increase sort of like clotting and stuff like that. And then the last two I just pulled out of my ass. So stop.
look at this.
I guess kind of sad.
Yeah, it's okay, don't worry.
Oh god. Too easy.
It's a question to get people home.
You still even know. No worries. Thanks, man.
Come on, go ahead.
Okay, well, this was pretty straightforward because it's like the opposite of the previous question.
Yeah, low blood glucose.
Yeah, it's definitely low blood. It's
I enjoy the backstabbing. It's definitely vasoconstriction.
If people actually answer blood glucose, I'm gonna die.
Oh, good. Okay, good job.
yeah.
Yeah. Yeah, too easy. There are a lot. These people have to read them. You remember the things that happened? Okay. Well, we talked about this today, and yeah, paraventricular, we didn't talk about that at all, so just forget about that.
Oh, I like it.
It's low levels.
Is that from the last lecture?
There's like, I was reading about male androgens, and all of a sudden, like, I dumped in the guy was getting Okay, so that was highly wrong. If you go into lecture 3, it says that low levels of male gonadal androgens have been associated with accumulating excess visceral fat. So it's low levels that cause more visceral fat in males. Lecture 3, guys. Look
And
through
make
it.
sure to know for females as well. It's like the same. It's also low levels. So.
Big oof. Oh, this one. Did any of the pictures show up? Did any of my pictures show up?
I don't know. I didn't put any pictures for that.
I put some pictures, but I was really lazy.
Anyway, this one was from the very important slide that we need to know. So make sure to know
Yeah.
that. We looked at it during tutorials as well. So.
Okay. What's the tricky question?
Put an image.
The single image that I put in. Because I don't even remember this question.
You put the image though.
I did put the image.
Oh. Okay guys, it's N1. It's also from the same slide as the previous question, so make sure you know that slide. Oh, actually never mind. I don't know what it says.
It's kind of obvious.
Yeah, because I was like, I don't know how to. It's like
it's
all
like,
three
no,
is like optional. It's like there's just one.
Literally read every test. This looks different.
Unless you can just like, okay, this is bad, this is bad, this is bad. Okay, there's like only one that's good. Yeah, that's pretty obvious.
Okay, so this is from that slide that talks about the study where they use the stem cells within the heart,
Yes.
that thing.
The adipose. Yeah, make sure you know like the experiment also with adipose tissue.
We're trying our best. Big ooh, good job. Yeah. How many do we have left?
We're at
Question.
17 out of 27.
Oh, this time. Yeah, we can skip some.
I think this is my last question, so I think the rest is Dr. Juice.
We don't need to do all of them. I can actually just put them as how would we collect all these questions and post it for students?
They can actually search it up on Google themselves.
Okay.
If they really want, we could post a link online.
Okay.
Yeah, so we saw that today as well, a bit about dysthemia.
Okay, let's keep going. It's bolded for a reason.
Why are these so mean?
Very bold. Oh, why did they get bolded?
Because if you you put it bold on a computer or something, then copy and paste.
Okay, that sounds bad.
I can't remember who did I did the same thing. I bolded my correct It just copied and paste. I bolded and italicized. I only caught it because of the italicized.
Well, just skip it.
I think we're gonna need about 5 minutes or so. If you guys can just let them know that we will send out the link, I'll post it for you.
Should we end it now?
Is there a way to figure out who's the winner?
Yeah,
Just
it's
look
in
at
the
the
leaderboard.
scoreboard after this one.
Okay. Well, that was literally bolded. Okay, should we just end here? Should we do
Yeah, let's just do this question and then we'll,
And then end it.
yeah.
Okay, we're gonna do this.
We'll make 20 the last question. We'll make 20 the last question.
I'm still fine.
CDA.
Yeah. Okay. We'll do one more question. This in? Cut it? Okay.
Hey guys, we have some questions left, and we're gonna post them. Dr. G's gonna post them. So if you want to practice, okay.
But yeah, this was the last
Congrats
question.
to Shala group who won.
Who is Shala? Alright, nice.
good
Hey,
job.
nice. Hey. Alright.
No.
Do you want me to end the quiz?
Yeah, that's okay. Thanks for doing that. It's fun. You guys asked really hard questions. Alright.
Yeah.
Alright. Okay.
Oh, just yeah, you're good.
Okay. Okay. I think we're alright.
Yeah.
Alright. Okay, is it 1 or 2? 1. Okay, great. Alright, a couple of things just to wrap up, if that's okay with all of you. So sorry, it's a little bit longer, but thanks very much for doing that. It was a lot of fun. They asked really hard questions, so a couple of things just to make note of. Where I've asked you not to memorize numbers, there won't be like numbers. There will be for like euglycemia, for like waist to hip ratio, etc. But triglycerides and stuff, you don't really have to memorize. So I just wanted to go back over a couple of things. So actually, we just decided here because we have enough space. We'll be in really tight quarters. Rather than split the group, we're going to just write everyone in here rather than try to get you over to the Banting Institute. Because there's normally a class in here ahead of time, we're going to ask you to just wait outside while we set up the room. And again, there are 4 different versions, etc. So we're all going to write in here. It will be a little bit tight for space, but I think we can accommodate everyone in the class. So please just show up here. It'll be 60 minutes in duration. Please keep track of the time. We will post the time up here for you on the screen. 15 multiple choice test questions, 10 short answer, 2 one-line answers, so just literally 1 line, 1 word, maybe 2 words, and then short answer, maybe a very small paragraph worth a total of 35 marks. Some of these will be problem-based, not quite as hard as the questions you had here. So some of them are actually pretty close to what I would ask. So I won't lie, some of them are very, very similar, especially the one about if you found M1 and you found this other molecule, what else might you find associated with it? That's the style of question that I normally would ask. So you'll see that. Covers only the materials from lecture up to today's lecture, everything that I had indicated to you. So there is a review session on Friday from 1 to 2 at New College. So on behalf of the TAs, I'm going to wish you good luck. And is there anything in this space? So I guess the key question here is, what does Omar want to ask me? Do you have a question you want to ask me, Omar? Is there like any questions that you guys do I owe you something or?
Yes, you asked 2 multiple choice.
Oh, is it 2? 2. Okay, so maybe I'm gonna troll you hard, maybe not. Do you have your cell phones ready? Omar, I'm a little bit sad. I thought you would be like right on top of it, but okay. Okay. So, are you really ready? Okay. Okay, I'm not. All right. Are you okay? You have two friends sitting right beside you who are also taking pictures. So, come on. Okay. Yeah, here's one of the questions. Right, terrible question. So that's terrible. So that's not one of them. It's not one of them. Okay, for real. So you can delete that previous picture for real. So I'm just going to read it first for anyone who's like at home or anyone who's left a little bit early thinking the credits weren't going to roll. So Ariana is a research biologist studying the role of mitochondria in metabolism. We talked a lot about mitochondria today, by the way, so you should probably go back and make sure you know that. How this role changes in healthy versus disease stage. She wants to generate antibodies that will help her in staining and visualizing mitochondria to compare their function and control versus DB mice. So basically it's asking you, if you think about it, what are good markers for mitochondria? Okay, so think about that. You learned a couple, and you should remember to go back and study this for your term test. Are we good? You guys all have your pictures? You're not sure if you got your pictures? Okay, I'll assume that you have your pictures. Next. Ready? All right. So again, this is one of the styles of questions that I typically like asking. So clinician enrolling candidates for a study on metabolic syndrome. Remember, you're not responsible outside of glycemia, euglycemia, numbers for any of those measures. The ratio for HDL, etc., that is something you're responsible for, not the level of specificity here. So what would you normally not associate with it? So you have to kind of know the markers for metabolic syndrome. That's what this question is asking. Are we clear on that? So make sure you were reviewing all of your markers for metabolic syndrome. Several of them came up here today in the Kahoot, so I think you are all on the same page. Are we good? So that's like question 2 that you'll see. If you know this and you've studied with your friends, it'll be like a really straightforward one. Are we good to go? Continue going. Okay, part 2. So which one of the following would, if he inhibited, so here you have to know what IDO is, and you have to think So we went through two different pathways. What happens if you inhibit the activity of IDO? Okay, and choose the most appropriate response. So you might be able to guess some of the answer choices now, right? Are any of you thinking like serotonin or 5-HIAA maybe as a possibility? So kynurenine would not be a really good answer here because that's like pushing it to the IDO pathway. Quinolinic acid would not be a good choice here. Do you understand the reasons why? So you're good? Do you want more? Do you really think I can give you more? Okay, so there's lots more for you. You get 12 more of these next Tuesday, 3:15, 4:15. There's no class after. You get 10 one-line answers. One small thing to think about. Please go to your tutorials. You're going to be allowed to take your practice tests with you out of the tutorials. You'll take them up. Some of that will be useful for you for term test 1. So please make sure you're going, okay? I can only tell you that it will be very, very fair. As long as you've studied, it should be like fairly straightforward for you. Okay, so have a good week. Go to tutorial. I'll see some of you on Friday. And thanks for everyone who did the Kahoot.
Professor, just wondering, what should we know about
I told you, you don't need to know anything.
alright, thank you.
Hello. I'm okay. How are you? Usually, because it involves like multiple systems.
Yeah, right.
Blood
I'll do twins.
pressure is related to the heart.
I think you're good with that. I'm just trying to tell. You guys could look at it.
Usually,
Yeah, it's fine. Yeah.
just one.
Right.
So, for
Making
example,
sense.
elevated
Streaming.
heart, elevated